Hello and welcome. Today we're going to be looking at the unit test for forces and motion. This is our first topic in high school physics, both honors and standard. As always, we're going to be going through all of these questions to make sure you understand how to approach and solve these physics problems and are ready to do well on the physics exam. Let's get started on our first question. Here we go. A 1,000 kilogram car experiences a net force of 3,500 newtons from its engine. Calculate the magnitude of the car's acceleration, and we should have two significant figures. Well, we know that force equals mass times acceleration, right? Newton's second law of motion. Meaning that if we divide by m on both sides, we get that acceleration equals force over mass. Force over mass, which is going to be 3,500 newtons over 1,000 kilograms, which is going to be 3.5 meters per second squared. 3.5 meters per second squared. Let's keep going. Two bowlers accidentally roll their bowling balls down the same lane, and the two balls collide with each other. The bowling balls are moving with equal speeds, and their speeds are the same before and after the collision. Okay, let's see. So, what's going on here? The bowling balls are moving with equal speeds, and the speeds are the same before and after the collision. Okay, so we know that momentum is P, and that equals mv, mass times velocity. Okay, so now we can write the total momentum before can be m1 v m1 vi, right, for initial, plus m2, but it's also going at the same speed, so vi still. And at the end, you have the same mass, m1, at the same speed, vi, plus m2, which is also going at the same speed. Alright, so you see here, this is the momentum before the collision, based on what they told us. And this is the momentum after the collision. And it's the same thing. Right, so these two are equal. So the momentum is the same before and after the collision. Alright, so the answer is that momentum is conserved. And we want a justification for why? Well, let's see. There's no external force applied during the collision, right? So if we want to talk about momentum, we can also talk about impulse. Impulse is the change in momentum. Impulse is the change in momentum. We can also write it as J. We can write it as delta P or J. And we write it as force times time. Right? Force times time. We can write it like that. Alright, so this is change momentum equals impulse J equals force times time. J is 0 since there's no change in momentum, which means that F has to be 0. There is no external net force applied, right? It's in its own system. It's in its own closed system. There's no external net force, so momentum is conserved. So our answer here is going to be A. And we can keep going to the next question. A red wagon with a mass of 7 kilograms is moving with a velocity of 4 meters per second straight towards a blue wagon at rest. The red wagon's mass is 7 times the mass of the blue wagon. The final velocity of the red wagon is 3 meters per second. Okay. Asking us for the velocity of the blue wagon immediately after the red wagon collides with it. Okay. What do we have here? I'm going to draw a little picture here, okay? So, red wagon. There's a red wagon right here. Red wagon. That has a mass of 7 kilograms. And it's moving at 4 meters per second. And then there's just a blue wagon at rest. There's a blue wagon at rest. Okay, and we're told that the mass of the red wagon is 7 times the mass of the blue wagon. So the mass of the blue wagon is a seventh of 7 kilograms, which is 1 kilogram. And it is static, right? So it's moving at 0 meters per second. And then the final velocity of the red wagon is going to be 3 meters per second. So still 7 kilograms. Kilograms moving at 3 meters per second. 3 meters per second. And we have a 1 kilogram blue wagon still. I want to figure out its velocity. So this is the diagram that I have. Alright, I've color coded it to just make it a bit easier to look at. So right here you have, this is the initial one. Right, so you have 7 kilograms at 4 meters per second. Here you have 1 kilogram, 0 meters per second. This is what's going on to begin with. And then this one collides with this. And then you have 3 meters per second here. And this one has question mark meters per second. I don't know. Alright? Now, the momentum is conserved, right? There is no applied force. There's no external net force. So the momentum is conserved. Momentum in the top is going to be 7 times 4, 7 kilograms, times 4 meters per second, plus 1 kilogram times 0 meters per second, which is going to be 28 kilograms times meters per second. And that is the unit for momentum, right? There is no other unit. And for the second one, you have 7 kilograms times 3 meters per second, plus 1 kilogram times question mark meters per second, which is going to equal 21 kilogram meters per second, plus question mark kilogram meters per second. And 28 has to equal 21 plus the question mark. So the question mark is going to be 7 meters per second. 7 meters per second. That's the velocity of the blue wagon immediately after the red wagon collides with it. And we can keep going to the next question. Amira and Dana want to move the piano in their living room. Amira pushes from behind with a force of 300 newtons, and Dana pulls from the front using a rope with a force of 200 newtons. The piano has a mass of 180 kilograms, and the friction force of the floor on the piano is 230 newtons. Okay. So, as always, in physics, one of the best ideas, especially when dealing with these mechanics portions, is just drawing a diagram. Right? Just draw a diagram of what's going on. It helps to visualize it. And instead of all these numbers, now I have a diagram of what is actually going on, the forces in all the different directions, right? So I have a piano, which I'm just gonna represent with a box, because it's kind of easy to draw a box. All right, so I'm gonna push from behind with a force of 300 newtons. Okay, so 300 newtons. 300 newtons here. And then Dana pulls from the front using a rope of 200 newtons. 200 newtons. The piano has a mass of 180 kilograms, and the friction force of the floor on the piano is 230 newtons. So now I got 230 newtons pushing back against the direction of motion. So 230 newtons. And it's 180 kilograms. Okay, so this is what I'm left with right now. Right, that is it. 230 newtons to the, what is that, left? Yeah, left. Then 300 plus 200, 500 newtons to the right, and 180 kilograms. Well, 500 newtons to the right minus 230 newtons to the left is going to be 270 newtons as a net force divided by 180 kilograms. Right, force over mass equals acceleration. It's going to give me 1.5 meters per second squared. 1.5 meters per second squared. And we can keep going to the next question. Part of a demonstration, the teacher simultaneously drops a 0.5 kilogram orange and a 0.20 kilogram tangerine from the same height. Which object has a larger momentum when halfway to the ground? Okay, so let's think about what we have here. So momentum is what? Momentum is mass times velocity. Okay, now how does that apply here? Well, you're dropping two things from the same height and there's no air friction. So that means that they're going to travel at the same speed the whole time. Did it hit the floor at the same time? Same acceleration, same speed at all times. Okay? So when halfway to the ground, they're going to have some amount of speed. And that speed is going to be the same for both of them. So the velocity is constant. But the orange has more mass than the tangerine. Okay, now momentum is mass times velocity. If the velocity is constant, but mass is bigger, the momentum is bigger. So the larger momentum is going to be the larger mass, which is the 0.5 kilogram orange. So the orange is going to have more momentum. And we can keep going to the next question. In the diagram below, each arrow represents a force of equal magnitude. Okay, so if we have a force of equal magnitude, right, that means that when we do the net force, this one is going to cancel out with this one. And now we just have something going this way. So we have a negative acceleration because we're going in the negative direction. Negative acceleration. Let's keep going. Okay. A red sled slides across a sheet of ice towards a stationary green sled. Two sleds collide and continue sliding together. Alright. After the collision, what is true about the velocity of the two sleds? Alright, so this is going to be what we call an inelastic collision, right? So you have two things moving, and actually you have, one thing is constant, the other thing is moving, and then hits, and then they both go together in the same direction. Alright, so the red sled is going to have some amount of momentum, has mass and has velocity, and it's going to conserve that momentum. Okay, so when it hits, then what? When it hits the green sled, then what? Then they're both going to go with the same momentum but more mass. If the momentum p is the same but you increase the mass, then since momentum is mass and velocity, if you increase the mass, velocity goes down because momentum is constant. So the velocity of the sleds is going to be slower than the red sled velocity. So the sleds are moving slower than the red sled was before the collision. That's generally true of all inelastic collisions, right? If you have an object moving at some speed towards a stationary object, once they hit, they're going to go at a speed that's slower than the one moving was originally. That's always true. All right. Two pieces of clay collide and stick together, moving in one dimension. Clay 1 has a mass of 2,100 kilograms, and clay 2 has a mass of 2,500 grams. Sorry, it was all in grams. None of it was in kilograms. Clay 1 has an initial velocity of 20 meters per second, and clay 2 has an initial velocity of negative 10 meters per second immediately before they have a perfectly inelastic collision. Okay. So, let's see. So we can make this 2.1 kilograms and 2.1 kilograms and 2.5 kilograms because that just looks nicer, right? Rather than like 2,100 and 2,500. Now, clay 1 has an initial velocity of 20 meters per second. So 20 times 2.1 is going to be 42 momentum units because you get tired of saying kilograms times meters per second. So I just said momentum units. It's not an actual unit. It's just something I put in there. That's kind of like a placeholder, you know? And then negative 10 times 2.5 kilograms is going to be negative 25 momentum units. Then you add that up to 17 momentum units. Okay, 17 momentum units. And they now have a total mass of 4.6 kilograms. And they're inelastic collision, so they're moving in the same direction. They have 17 mass units. Alright, 17 mass units. I mean, not mass units. This is why you put the units. 17 momentum units, sorry. Divided by 4.6 kilograms. So if we want to find the final velocity, they're going in the same direction. So positive 17 over 4.6 is going to be 3.7. 3.7 is our answer. And we can keep going to the next question. Ralph wants to move a 60 kilogram sofa. He applies a force of 480 newtons. Under these conditions, the sofa initially moves with an acceleration of 3.20 meters per second. So the net force equals a mass and acceleration, right? So this is in second line, right? F net, the net force, is going to equal mass and acceleration. Now mass is 60, acceleration is 3.2. So 190 is going to be the F net. So F net is going to be that 480 here, 480, but F net is only 192. So to the left, must be a force of 480 minus 192, or 288. that would make it the net force less. So it would make it 192. So the friction force is going to be at 288 newtons. And we can keep going. Alright, so that was the unit test on forces and motion. We covered a lot of things in the topic of mechanics. We covered momentum, we covered a bit of work, energy, and power, plus we covered forces and motion. Alright, so I hope you enjoyed this video. I hope you learned something from it. If you did, please be sure to like and subscribe. And I'll see you next time we continue looking at more physics topics and more physics problems. I'll see you then.